So I am Mayur Rele. I am currently the Senior Director of IT and Information Security at Parachute Health. So I'm into IT and security industry for more than 15 years now. And then recently I have been writing some research papers for knowledge sharing with the community. I'm also a part of technical program community for IEEE and other journals. And I'm also the reviewer and the cybersecurity leader, and then promoting cybersecurity hands-on trainings and other things in other forums. So we'll start with the presentation. So why threat modeling, and why threat modeling in the cloud? Because all the modern architectures are designed in the cloud now. The traditional data center is hardly used. What are the key threat modeling methodologies? We'll look into that. What are the different cloud architectures? And then how the clouds are designed on the back end, and then how do you integrate the security flow? How do you look into the sample cloud architectures, and what are some of the best practices? We are going to look into this. So what is threat modeling? So threat modeling is an approach to identify and prioritize and mitigate threats. So threats could be anywhere in the cloud. So you have to find the asset. So, and then you have to tag the asset. So asset could be PHI, PII, it could be EC2 servers, databases. So that's how you classify the assets. And then you classify the threats. What kind of threats are in your cloud? So you have to do a threat assessment, and then we'll look into that, how we conduct that. So you also have to do a vulnerability scanning and vulnerability assessment. So this can be done with the static or dynamic scanning tools. There are different tools for the clouds as well, which can give you the visibility on what vulnerabilities exist. And then the mitigation planning, what kind of vulnerabilities are really relevant. So you are going to look into critical, high, medium, lows, and then information, what's relevant to you. And the goal is to add the security in the design phase. So you have new projects coming up in the cloud. So you add the security along with the block diagram, like what needs to be done for the project and what security we need to analyze for the project. So you start based on day one for the project. So every cloud has different needs, different platforms. We have infrastructure as a service, which is more complicated than platform as a service. And then software as a service is basically just the software. We don't have to manage much. Security there is just kind of a patching, upgrading the software. So benefits of threat modeling are reduced attack surface. So you're aware what vulnerabilities are there in the cloud, aligns with compliance. Most of the companies come in the compliance auditorium, like you have to do GDPR if you are in Europe, you have to do HIPAA if you are into healthcare, you have to do SOC if you are into a cloud. So it depends on your business needs, what kind of compliance you need. And then better best practices for DevSecOps integrations and other things. So based on the Gartner report in 2023, it says like the cloud breaches were happening because of the misconfiguration. So some of the best practices were missing. So we're going to see like how do we avoid the misconfigurations. So these are some of the key threat modeling methodologies. So some of the best practices is Stride, Dread, and Pasta. So Dread was developed by Microsoft, which is a little bit deprecated these years, but Stride and Pasta is still in use. So in Stride, you look into spoofing, tampering, repudiation. So spoofing is like any other user logging as the original identity of the user. Tampering is like you're injecting malicious code into your config files. Repudiation, again, same thing, someone else logging on your behalf, there are no logs. Denying access to the real user. Information disclosure is like you're trying to expose some information on the internet, on the website. Some of the web pages are leaking out some of the private keys or some of the keys which are relevant, and which gives attacker an idea about what information you're disclosing them. Denial of service, again, it keeps your APIs and websites very busy with a lot of flood requests. And elevation of privilege is some kind of an admin access. So you are a normal user, now you figure out a loophole, and then you are getting an admin access, and with that admin access you're tampering and playing with the application. So you identify the threats using Stride, and then in Dread you get a score. Now my vulnerability for an example is SQL injection or cross-site scripting, and then you know how to reproduce that. So what damage it can do. So you give points based on that on the scale of 10. What's the reproducibility? Are you able to reproduce that every time? Can you exploit that if you are able to reproduce? How many users are affected? I think everyone in the organization, and then discoverability. How do you discover and exploit that? So based on that, you get a risk score, and then each vulnerability you put like a risk score. So now you know where you fall, and then how do you prioritize stuff. And PASTA is most probably an attack simulation, threat analysis. There are so many different tools available on the internet, like Burp Suite, Tenable, where you can do a vulnerability scan and later on exploit that. So the best way is to do the pen test using different tools, or hire an external company who can do a pen test and the team assessment. So that would fulfill the thing for the PASTA. So there are so many other tools which are cloud specific, like AWS well-architected framework, Azure threat modeling tool. This will give you an idea where the threats are in your organization, just like a list of best practices. It won't really tell you like, can this be exploited or not? It's like a very high level overview, but then you need someone who is like a technical hands-on and who can lead into each and every threats in the code, in the login, in all the softwares and all, end of life products, something like that. So different type of cloud architectures. Software as a service is super simple. We don't have to manage that. It's hosted by a cloud provider or service provider, and we are just installing the software like Slack, GoToWebinar, Zoom, Discord. These are software as a service. We just patch them when the patches are there. So we don't manage that. So maintenance is pretty low here. Platform as a service. So I have a code, I'm a developer, and I have a code to run, but I don't want infrastructure. So I just want a platform where I can run the code, like AWS Beanstalk, just upload your code, and then you have no visibility what's been done on the platform, but code is running, your websites are running. So, AWS Beanstalk, Google App Engine, AWS Lambda, these are some of the examples for platform as a service. So you can quickly run the code and then see. Infrastructure as a service is like for bigger organizations, startup, medium-sized businesses. Now you want to manage your own infrastructure. You're a company who wants to design your own storage, you want to compute your own resources, you want to use containerization, you want to use your subscription for different softwares. Now you have to use infrastructure as a service. So Google Cloud, Amazon, Microsoft, Azure, there are so many open source clouds as well that you can use. So that's like infrastructure as a service, and that has high maintenance. So this is basically the hardware design. In software as a service, you're just responsible for the application. Platform as a service, you're just responsible for the middleware and application. Infrastructure as a service, you have access to the guest OS, Linux, Windows, and what you want to use, customizations and all. And some of the networks using VPC, middleware, and the application. But you don't have the visibility on the hypervisor, like whether it's VMware, Citrix, what's being used by the cloud. You don't have access to that. There might be some KB articles where they disclose that information, but you don't have access to the storage, whether it's Dell, EMC, what kind of hardware is that, and what kind of network is that, whether it's Cisco, Juniper, or any of the open source there. So you have no visibility there. You don't manage that. So this is the basics there. So this is the basic cloud security flow. Think of it like you are an user, and what are your security challenges? So there are challenges faced by the cloud user, and there are challenges faced by the cloud provider. So the cloud user could have challenges to access the cloud as a software as a service or infrastructure as a service. How do you access it? How do you manage your logins? How do you manage your MFA? The cloud providers, they have whether you are a real user or you're trying to attack, how do we protect our resources on the internet? You are visible on the internet. If you have some ports open, then how do you, that are their challenges. And then you look into the delivery models, what's best fit for your organization, whether it's software as a service, platform as a service, infrastructure as a service. So infrastructure as a service, then we dive deeper, like what kind of apps you are hosting, whether it's mobile apps, web apps, what kind of services, how are you communicating on the internet, and what ports are open, 8443, how are you doing an SSL offload? SSL is pretty much required everywhere. It's one of the best practices from last few years. And then even the information you're taking, like login pages, that has to be encrypted with SSL. But there is some information on the internet that doesn't need SSL as well. But I would recommend we use SSL across the whole site just to be safe and secure. So now how your decryption happens, whether it happens on the ALB, and then how does it work from ALB to the application? Do you have a reverse proxy like Nginx, and you need again encryption and decryption there? And what's your application, whether it's .NET, Python, Ruby on Rails? So I would recommend that we do end-to-end encryption. So there are no unencrypted hops anywhere. So encrypt at ALB, encrypt at reverse proxy Nginx, encrypt at add an SSL certificate for the web stack like Ruby on Rails, Microsoft IIS, wherever you're hosting it. So it's end-to-end encrypted. And then later on, where you save the data, where you cache the data. So that data is in database. It could be Postgres, MySQL, MS SQL, or Microsoft SQL. Then that data has to be stored, and then that data has to be encrypted. So data in transit is normally encrypted with TLS, SSL, and then the data at rest has to be encrypted with AES 256. That's one of the best practices. And then when you take the backups, make sure the backups are encrypted as well. If you're in S3, you're keeping some data in Amazon S3, make sure the buckets are encrypted as well. So that's one of the best practices. So this is like a sample cloud architecture, very basic. Like you keep your DNS records in Route 53, you host the zone there, and then you send the traffic that resolves from DNS to Elastic Load Balancer, again dynamic IPs for ELB that could keep changing, and then you send the traffic from ELB to your web stack or the app stack. And the app stack could be containers or web servers, and then if you need to keep some of the application data, you can use S3 bucket. It's global for Amazon region. I'm focusing more on Amazon instead of Azure and Google Cloud. And then where do you keep your confidential data, PHI, PI, anything like that? That's normally goes to the database. And then that database is Amazon RDS. You normally develop a high availability architecture like master-slave combination or active standby. So if one database in one availability zone has a problem, so you can go to the standby, can be promoted as an active. You need CloudWatch alarms for every configuration in AWS, otherwise you won't know what the problems are. Email, SNS notifications, DynamoDB can be used for caching, user sessions, and then SCS for email. So this is like a very basic architecture. And this is the architecture 2, a little bit complicated than the earlier one. So here you put the WAF, and you configure the blacklisting, DDoS attack prevention, like WAF has integration with AWS SiteShield, which is a different product for DDoS. And ALBs also have limited protection for DDoS attacks, but they're not fully protected. And then WAF, you have custom rules in AWS, Azure and all. So you just have to look into the rules. Like you might see the rules from Zscaler, you might see the rules from Imperva, you might see rules from different WAF providers. You select what's best for your organization, test out those rules in staging, and then you can apply that. If you are doing business in US, UK, some of the countries, then just do a geolocation-based blocking in the WAF. It's available in AWS, and so that your website is not exposed from other regions, other countries where you're not doing business. So WAF normally is also connected to LB. AWS has that integration, and then WAF can have integration with SiteShield. So it's all integrated in one piece. So SSL certificates are required. Those will be from certificate manager. Easy to manage, easy to renew. You don't have to rekey it every year. It will be automated by Amazon. And then you have CloudFront if you want to cache some of the resources to serve faster, like CSS, JS files and all. So you connect that to Lambda, make it automated. All your images and CS and JS, those files can go in S3 buckets, so it makes it a little bit faster. This is one of the best practices, but different organizations might have different architectures based on their business needs. So here we are using ECS, like containerization, so it can auto scale based on the threshold. So you don't want to manage anything. You just design a threshold like auto scale based on more than 80% CPU, just auto scale my pods, and then CPU is less than 40% scale back. Same for memory, and then you can use a reverse proxy for after that. And then if you have a use case which cannot be containerized, have a legacy application that could be auto scaled with EC2 servers. Same, some of the caching hot data can be on Elasticsearch, your logs could be there. Redis can be used for session management, keep all the real data, tables, structured data in MySQL, Postgres or anything. Same, it should always be highly available, multi-region or multi-availability zone at least. Queuing, if you need some kind of a queuing, then you can use queuing for that. So this is some of the best practice, and then the configuration would change based on the business needs. So how do you develop and promote the code? So any changes in the cloud, whether those are security focused or application focused, go through source control, like GitHub or anything, GitLab, and then run static analysis scans like SonarQube. There are so many softwares there, automated on every pull request. So I want to implement AWS WAF and load balancer. So I would write the code for that in Terraform or some other technology, and then I would promote that in dev. I would test in the dev branch how it reacts. Copilot, nowadays AI has been used, so you can use GitHub Copilot. Copilot can do a review, and then you can take a review from your peer. So that's one of the best practices, so that Copilot will do all the AI review, peer can do the other manual review, and this is how you promote the code. Some companies also have preview where you can test your change in preview environment as well. So it depends on what your organization needs. But don't do any changes manually in the cloud, even for testing, because you have a security team of 5 engineers or 10 engineers. So one engineer is going and enabling guard duty. You don't know what changes he did. But if you have that changes pushed from GitHub, now you can track, oh, this was the change pushed by this engineer. So I want to trade on this. I want to make this change. So it's easier to manage. Starting it's a little bit tough at the start, but once you start writing the code, it becomes very easy, and it's very, very easy to manage changes in the cloud. So CI/CD workflows. So once you write the code, like Terraform, CloudFormation. CloudFormation is AWS proprietary. Terraform can be used in multi-cloud, Google, Azure, AWS, everything supports that. So you write the code in GitHub, and then in your source control, whatever it is, and then you want to push that code. So you need some kind of an automation, CI/CD tool. So GitHub has a good automation, GitHub Actions, so that can push the code in AWS. It's all connected. Initially, you have to do the connection using the API keys or the roles, but once that is done, then you can push your changes immediately in AWS. You can also design multi-cloud, multi-AZ environment in AWS, or you can keep different accounts. So you can keep one account for dev, you can keep one account for staging, you can keep one account for production, or you can keep same account with different VPCs. But I would recommend you keep different accounts so that it's easier to manage access for each account. And then you push code with you use CI/CD, Jenkins, Build Guide, GitHub Actions, anything. GitHub Actions is normally free and covered in business and enterprise editions. Super easy and simple. The other ones, Jenkins and Build Guide, they might have some cost. So anything that's easier for you. So these are some of the best practices, like cloud threat protection. So secure your VPC, like only open the ports which are required in the security groups. Log all the data if possible. VPC flow logs are huge, and that could add huge cost to AWS. So rotate the logs every few weeks. The logs which are not required, you can rotate them until you can. Segregate the networks like production, staging, test, dev, demo, and then don't keep any connections from staging, test to production. Keep production fully segregated. This is one of the best practice, and use AI. So Amazon has Guard Duty, which has machine learning, a little bit of AI, and some other technologies like Guard Duty can look into the attacks which are coming into the AWS cloud. It's mostly their IDS, IPS kind of a thing. You also have Amazon Detective, which can look into EC2 and other stuff. And then you can use OpenSearch or any other tool, same, to analyze the logs. So, but if AI is available, use AI, because you might have tremendous data, so you don't know what data you need to look. So you need some intelligence on same, like, oh, this is some off connections. We never do business outside of US, but you're seeing some traffic from US. So those logs should highlight what you need. And secure a database, keep them in a different VPC, only allow internal connections, make sure database are not exposed on the internet, because all you need is, like, we are running a web app which is open on the internet. Your web app is actually the app that needs access to the database. The whole users don't need access. So just allow the connections from your website, and make sure the storage is encrypted and it's all role-based. The passwords are not used. Maybe initially when you create a password, you can keep that in a vault, complicated password, and then later on use role-based for all the application needs. And secure a web stack, like put the web servers in the private network. You don't need DMZ. Your load balancers can be in DMZ. Load balancers talk to the web servers talks to the app database. So that's how you design the network. Integrate WAF, bot defender with the load balancer. AWS has been launching so many new functionalities along with the WAF. They have marketplace rules, they have bot defenders. So test on dev and staging first and see how it works. If you're able to get some data which is suspicious, you're able to detect that WAF requires login. Without login, you won't know what the problems are. Enable centralized logins and data to SIM. You could use Splunk, ELK, whatever is possible. If you have too much logs, use OpenSearch. There are some of the SIMs which are free and open source. You could use that as well. And only open the ports which are required. Most of the web app would need communication on 443. You can just use 443. If you're using AD, redirect AD to 443. Add SSL certificates. Test your ciphers on sslabs.com. Just make sure your web application has no vulnerabilities there. And these are some of the cloud threat protection best practices. Define scope first. Define scopes and assets. Like identify where your critical data is, applications and services. And then based on that, you roll out a plan. Map out the cloud architecture, what it's using, VMs, container API storage, where they're used. Your S3 buckets, if used, should be encrypted. Bucket deletion should require an MFA. You can do object level logging, versioning. All features are available, just based on the use case. Involve stakeholders. Bring all developers, architects, and security team together in weekly or monthly meetings. So you have visibility on what developers are working on. Developers have visibility on what security teams are working on. Iterate regularly, like update models, new services and threats. Keep looking on new products available on the internet, which are AI-based, machine learning-based. Test them out in their own staging accounts. Make sure any access to the cloud goes through SSO, MFA. So if you have Okta, Active Directory, ADFS, just integrate the cloud through that, so it's easier to manage. All the logging information and all the cloud logs should be monitored, and they should be correlated. Any changes in the cloud should be monitored. Most of the changes are available out of the box, like in Splunk, Lacework. There are different tools which can alert you on the changes. Monitor the resources in the cloud, guard duty, inspector, security hub, trusted advisor. This gives you the best practices and what are the loopholes in your application. Each of these services come with the cost. So test them in day one staging first, get an idea like how much the cost would be. Enable IDS and IPS as a network-based, host-based. There are so many products available if you don't want to use guard duty and other host-based, like I think Trend Micro. There are so many other products. Network-based, I think if you just Google network-based IDS, IPS in AWS, there might be so many Terraform and CloudFormation scripts available that you can test out, like open source products. Enable the WAF, Site Shield, GeoSpam protection, and then best practices. Site Shield is your DDoS prevention, and then WAF is WAF, like you have all the rules, OSWAP, top 10, and other things integrated there. Shut down the regions that are not required. So if you are configured in US region, like North Virginia and Ohio, maybe primary and backup, shut down the other regions in the cloud because you're not doing business there. You might accidentally deploy something that you're getting billed, or someone could exploit those. Configure multi-region if possible. So if one region is down, you have resources running in the other region. This is also useful for compliance. Multi-region and multi-availability zone. So there should be multiple availability zones as well. Alerts on any changes in the cloud, like deployment of EC2 servers, deletion of EC2 servers, deletion of S3 buckets, depends on use case. If you are scaling up and down on your EC2 and container stack, then these alerts would be very intrusive. So make sure you adjust the threshold based on the business need. Keep all configuration in infrastructure as a code, Terraform, CloudFormation, anything. So the whole team has visibility on who is managing the change instead of making a change in web UI, which is difficult to know, like who is making those changes. You can apply alerts on that, but it's still difficult to track. Enable CloudTrail. CloudTrail is AWS logging, like any changes in AWS, any tags, anything, that you will see the log in CloudTrail. Any read writes, anything in AWS, so it's pretty much required. Run regular scans, static scans for if you're writing the code, dynamic scans for your web app, so you're pretty much aware about the vulnerabilities. Automate where possible. Use open source or enterprise products like Laceworks and Trend Micro. They give you visibility on what's going on in your cloud. Like if someone is deleting an S3 bucket, you don't have to write alert for that. Laceworks has that written and integrated. It will give you the alert, like someone just recently deleted a bucket, and it will give you an ARN, go deleted that. Same with Trend Micro, it will give you the loopholes in the cloud, like if your resources are overly provisioned or someone is not rotating their keys, So these tools will give you the visibility. You don't have to configure anything out of the box functionalities. They are also available in AWS Marketplace, so you can subscribe, test them out, or reach out to vendor, do a 30 days proof of concept, see if you see any value with that. Align with compliance, like each company has compliance needs, like ISO, SOC, NIST, it depends what kind of business you are. If you're taking credit cards, you need PCI. If you are working on the cloud security, you need SOC. You are international, you might need ISO. Some of these are required, and then these should be attested by third-party auditors. So these are now, let's look for the tools for threat modeling. So open source tools are also have Threat Dragon. So as you can see in the picture, you can download that for Windows or Mac, and then just import your block diagram there. And then this is manual, so you have to figure out what the problems could be and then highlight them. So this is different than your network diagram. Network diagram is a little bit different. You don't know the vulnerabilities there. Here you can tag on the vulnerabilities. So it's a little bit different architecture. And then you also have Python threat modeling, same thing. Also have is web UI, you can download and configure it. Python is mostly code based, so you have to install it. It will give you similar architecture. And this is your threat diagram. So you want to see where the threats are and where you want to improve that, and then you iterate that on every few months or every year. So cloud native tool, Security Hub, it will correlate all the data from Cut Duty and anywhere in AWS. Same with Azure, they have Azure Defender. They have we also have Google Cloud Security Command Center, same thing, different cloud versions. So if you're looking for commercial tool, then the Threat Modeler, and then the other one, Iris Risk. These ones can be used. These might have pricing, but they might be automated. They might automate your network diagram. They might look into the risk. They might highlight the risk. So initially in the open source, you're doing it manually. These people might do it automated, and then you have to check whether these risks are there and what protection you have in place. So rising cloud cost. Every time you make changes in the cloud, there is a cost associated with that. So how do you manage the cloud cost? So you need right sizing if you're on RDS, EC2. So you need tools for that. So ProsperOps is automated tool. You don't have to do anything. You just configure it, give access. It will keep on right sizing by itself without letting you know. You can get the reports. You can get the alerts if you're required. But so I'm using an M5 large, and then I'm heavily underutilized. It will go from a large to some other instance size. So it's super easy. There are other tools like Cloud Health, Cloud Zero as well. Add resources to reservations. You think you're going to use this web stack for a longer duration. The database is not going to be changed. Add it to reservation. You save on the cost like 50, 30, 20%. Ask for credits from the cloud providers. Make use of spot instances for your web stack. It's a little bit cheaper than on demand. Use microservices and containerization. Wherever possible, use pricing calculators to get the budgets and estimates, so you have a budget on what you're working on in the cloud. So some of the layered system of the security controls. So foundation controls, you need like a perimeter, which is a network security, firewalls, and intrusion prevention. So you can put your own firewall, or you can use VPC and security groups. It's basic. It's normally used in the cloud. Normally people avoid using Palo Alto, Cisco firewalls and all in the cloud because it's all VPC, security groups, and network ACLs. But you need intrusion prevention like network-based host space because you're using that. User access provisioning, role-based access. Just give access to the users based on the role and the business needs. There is no required functionality to give admin access to everyone. Admin access can stay with IT and security and the people who are really working on the cloud. Access management, and then the developers and the other users can get role-based access to production based on needs, like some of the application access like S3, RDS, EC2, whatever they're working on. Full access is not required. Vulnerability management, make sure patching has been done. This can be automated using AWS Patch Manager in AWS. You're running scans for patching. You have all the controls, changes in the GitHub that you're making in the cloud. You have a formal incident response plan configured. So security awareness training for developers and the whole organization, so they are aware what's going on in the security world. Organization, same stuff, role-based access to everyone, and then the compliance like policies, procedures, e-discovery, and audit. So these are just the basic foundations. If you want good controls, it's a combination of foundation plus good. So it should be measurable and repeatable. You have formal detection and response plan. You have log analysis being done. You have SOC team looking into the logs. You have user behavior logs, what IPs they are coming from, what states they are logging in from. You have server scans running every day, automated. You have pen tests by some external company at least once a year. You have data loss protection enabled. So if someone is downloading S3 bucket data and all, it should be restricted. You should be getting alerted on that. So there are so many products for DLP, Nightfall, Zscaler, so many you can configure. Risk assessment, your team needs to do a risk assessment on the cloud, IT risk, DR and business continuity plan should be tested at least once a year, whether it's functional or not. And then you should also do a third-party risk assessment, the products and the sub-processes that you're working on. Like if you're working on AWS, do a risk assessment on AWS. Look into their SOC reports, like SOC 2, SOC 3, it's all open. Like you can download from your account and then look into their best practices, how they're managing their data centers and all. Governance, like governance committees, change management, identity access governance, strategic planning. If you have a small security team, you may not have governance, but if you have governance team, use GRC products, work with the legal for some of the process. And nice to have, align with the business, define the key risk indicators, perform the risk assessments on your infrastructure, reduce technical controls, promote everything to infrastructure as a code, and then the risk management, like what are the risks? How do you fix the risk? You might have some critical, high, and medium. So now you have just too much in your plate. Fix the critical and high first, and then you can discuss on mediums. So, and based on the scenarios, you also have to check whether this risk, like this is an SSL risk, but can this be really exploited in the real world scenario? So, cybersecurity program maturity. So, initially, just start with review, hire a security team, develop a new set of policy and procedure. So you write the policy and procedure first, and then you implement those controls. Initiate a strategic program, design your architecture, look into what's been done now and how do you include security with the development. Formalize a formal process so that the developers work with you, your engineering team works with you on security. And then conclude and catch up projects. Every new projects come in, security should be by default involved in making decisions. Track technology and business changes. Everything should be going through change management, tickets for every single change in your change management system. Could be Jira, ServiceNow, Manage Engine, anything. Continuous process improvement, like try to improve your process every time. So now your program is getting matured. You started from initial, now you are developing, now you are deploying, later on you are managing and you are optimizing. So that's how your program works, and then your risk goes down based on that. Yeah, so that was it. Let me know if there are any questions or anything I could help you with. So this was not super hands-on app, but if you need an hands-on, we can do another session for that. But let me know if there are any questions and how could I help you. Yeah, insider threat program is different. So you should definitely do the insider threat program. It's like a different thing. It's focusing most on the insider threats. This one, the threat mitigation for cloud is a little bit different. It's like exposing your resources on the cloud, how they are being utilized and what are the threats from the hackers, and the other ones, the insider threats, mostly focusing on your insider threats, like, what are some of the users who are not aware about cybersecurity, who can click on the phishing links and, they could log in, they could expose their credentials. How do you manage that? And then what's your threat score based on that? So insider threat assessment is very good, and every company should do that at least once a year, or if you can do it once a quarter, that would be great. But the cloud threat assessment is very different than that. Cloud threat assessment focuses more on hackers trying to exploit your web application, your cloud, and getting access to that. So yeah, both are equally necessary and both are a little bit different. Yeah, definitely. Yeah, multi-hyperscaler would be useful, and then I would need more insights on how you're trying to configure that. But I think that would be a recommended practice. But it depends like how you're configuring that. But I would definitely recommend that you do multi-cloud, and then you do auto scaling for all your architectures. But anything that's latest, and then that's adding more redundancy, adding more scalability, should be definitely used. So security categories, like you have to categorize the security. So the threat diagram, you can go back to the threat diagram. So security categories, we are just classifying them like the security issues faced by the cloud user, like what issues you're facing, like logging in and accessing the cloud, like how you are logging in, whether SSO, MFA, IAM, and then the security issues by the cloud providers, like what are some of the issues by the cloud providers, like how easy it's to access the cloud, what are their backend problems. Some of the cloud providers may not have security attestations for all their products. Now, AWS recently launched Bedrock and other functionalities. So at the start, when they're launching, maybe they are not, HIPAA compliant. So maybe that data is not segregated and shared, but you don't know what the risks are. So you have to know the security issue faced by the cloud providers. You have to look into their audit reports. So AWS has all the compliance and audit reports in a portal. So as far as you have access to any of the cloud provider, you can look into their SOC 2, SOC 3, SOC 1, HIPAA, High Trust, ISOs. Most of the cloud providers have every attestation, FedRAMP, if you're doing business in Europe, GDPR and all. So you look into that and then see what are some of the issues faced by them. And then that's how you categorize the risk. Now, your cloud user risk is different than the cloud provider. Yeah, so there are so many cloud security posture management tools. Trend Micro, Laceworks, Tenable, they all can do cloud security posture. You can also use Trusted Advisor, Guard Duty, Amazon Detective, Amazon Inspector as well, and Google and Azure might have similar tools. But Laceworks, Tenable, and Trend Micro are really good tools. So they will give you the benchmark of your cloud, and now you are looking for a SOC certification. So based on SOC controls, how are you doing based on SOC controls in your cloud? So Amazon is attested for SOC 2, SOC 3, but you are using Amazon for yours. So are you in the best practice or not? So that Laceworks and Tenable, Trend Micro, they will give you the insights. So maybe some of the S3 buckets and EBS volumes are not encrypted. It will show you some of the keys, API keys or access keys are not rotated like every 90 days, 180 days. Some of the passwords are weak, and you have some web apps exposed on some non-standard ports. You have some less secure apps configured. So it will give you the loopholes based on the scanning, and then you create tickets based on each, and then just make sure that these issues are fixed. So, but these tools are really, and then there are so many other tools in AWS Marketplace, and then you can reach out to the vendor, conduct a POC for 30 days. And then see if you see a value. If you don't want to conduct a POC, you can go in Marketplace, subscribe for a month or something, test it out. If you don't like it, you can cancel it. But this will really give you insight. So we have been using different tools because AWS native tools are sometimes expensive, and these third-party tools are fixed price. So they will just look into the resources and give you the loopholes and best practices on how to configure. Yeah, so most of the common model applies to most of them. So you might have different services by different names. So Amazon AWS Inspector could be called as something else in Google and Azure, but the model is pretty much same. So you work on the base model, you identify the risk, and then you figure out what cloud products you want to use, or you want to use third party. So model is pretty much same, Yeah, you can. Normally, the best practice is to use it before the threat detection, so you really know what your threats are. So you're starting a new project, so maybe you're migrating from data center to the cloud. You would use threat modeling now, because now you are designing it. You have network diagrams and block diagrams ready. So use threat modeling now and then see what could be your threats, and then you get more visibility. So if you're already into cloud, everyone is into the cloud now. So you can start now. So you want to start now on threat modeling. Just map out all your architecture diagrams, and then based on the architecture diagrams, see where the threats could be. So there are some automated tools that will do for you, and there are some manual tools that you can use, and you can quantify the risk. And wherever you see the risk, create tickets on that, and then based on the risk, you need to reproduce them, and then you need to make sure how you are going to test the risk. So and then once you are able to test it, then you need to figure out like how do we fix that, and then after the fixing, how do we try that again. So this could be anywhere from critical to low. If it's an exploit and it's exploitable, then it should be shut down immediately and it should be fixed immediately. If it's not exploitable, then you can define maybe critical, you can define like 24 hours to 5 days. High could be 5 days to 10 days. Mediums could be 15 days to 30 days. So each based on the organization, nature of the business, you can define the risk. Yeah, so there are so many tools used. So nowadays, recently a lot of tools came up like Data, Vanta. These are some of the auditing tools. So if you're doing PCI, you're doing SOC. So Data and Vanta, these tools can integrate with your cloud providers, and then they can also look for the best practice, similar to what Laceworks and Tenable does. But your auditors can actually do the audit. So now when you're doing the audit, whether it's high trust, SOC, ISO, you have so many audit items to do. So this Data or Vanta, and then there are so many other tools, risk cognizance. You just have to Google what are the competitors, and then you look they look into your cloud, they look into your best practices, and they based on the compliance controls where you map. So your compliance control is access control, access modification. So based on access, now how it maps to AWS, whether you're rotating keys, your passwords are complicated, how you're logging in, it will look into that control. If it's a database control, like logging into database, IAM based, password based, it will look into that control. So these tools map with the cloud controls and the frameworks, and they give you more visibility. So you can use them, and then 80% of your audit would be automated. So, and then auditors actually will use Data, Vanta, risk cognizance, and then third party trust cloud and all to do the audit. So this is like a very automated and preferred approach, and they have been in the market from last 2 to 3 years. Yeah, you can. So if you're into public cloud, there is an option where you can use your own keys, but normally the best practice is to use the keys in your cloud. So AWS has a way to generate and manage the encryption and the other keys in AWS. It's a simple approach, and everything is managed there. So it's very difficult to hack into those keys because you need access to the cloud account. But if you want to bring your own keys, that's fine. It just makes the management of the keys a little bit difficult. But if you're using a cloud like AWS, Azure, Google Cloud, you can manage the keys there. They're safe. Like AWS can manage their keys, whatever you are configuring. So you don't have to bring your own encryption keys. Yeah. AWS has a way to generate and manage them. And it's automated with Terraform and infrastructure as a code. You can automate that. Yes, I would recommend that you just start some asset inventory in basic Excel, or if you have a tools like Manage Engine for that, you can do it there. But qualify your assets, like what you're using, where the critical data is. If the data is not critical, then it would be a low risk. But just figure out where your critical data is, like PHI, PII, Social Security, credit card numbers, PCI and all. Where is that data? So you have to qualify the assets. Like if your EC2 servers have no access to the critical data, they are not critical at all. So then your database has all the control. So your database is the critical asset. So you need to do the pen test, you need to run all the vulnerabilities for the databases and then see where the problems are. So you have to figure out where your critical assets are. You're keeping some confidential data in S3 buckets. So now S3 buckets are your critical assets. So you have to tag them. So you have to maintain a list of inventory, and then you put a tag based on that. So it could be production, it could be PCI, something like that. So, and based on the tags, then you know where your critical data is, and now you aggressively pen test, try to exploit, do a red team, and then see where the problems are. So, pen test is normally conducted by third party company and would recommend that, and the red team can also be done by third party. So, you get more visibility. So, now it's not just you, and this can done once in a year. So, and there are so many companies who do that. So these companies will actually look into your practices, and they will try to exploit, find vulnerabilities. So now you know that you did the threat modeling, but you're still missing the gaps. Now some outside third party auditors, and the pen test company did the audit, so they were able to find these gaps, these vulnerabilities in the code, and then based on that you create a mitigation plan and you fix it. Yeah, so if you're starting with cybersecurity, you can start with some basic certifications. EC Council has CEH, which is Certified Ethical Hacker. It's very technical. If you want to go in a technical track, it will give you information on how to exploit the web stack, and then how to exploit the vulnerability. It's very technical, hands-on. If you are looking more kind of a general guidance about the processes, governance, risk assessments, and the frameworks, best practices for compliance, you can try CCSO. So that would give you more visibility on the management process of that. So yeah, there are different ways you could exploit. There are a lot of YouTube videos. There are a lot of webinar series. There are a lot of blogs. So most of the information is available on the internet. So just